Okay, so what I wanted to talk to you guys about today is understanding the notion of similar polygons. So, understanding similar polygons. And this comes out of lesson 7-3. So we're going to cover some vocabulary, and the first word we're going to talk about is the word similar. We've talked a lot about things that are congruent, that have the same shape, same size, but what we have here for similar is two figures that have the same shape but different sizes. Now, we're going to talk a little bit more in detail about what that means, and in particular, we're going to relate it back to polygons, which is in our title. And similar is just, there is actually very measurable relationship that they have. Now, there is a symbol that we use, and it's like the tilde symbol in Spanish, and because we want to say it's not the same exact thing, it's like the other one. So it's kind of like half of an equal sign, all curvy. All right, so let's talk about similar polygons. So similar polygons. What we have are two polygons. So any three-sided or more shape whose vertices match up. And what we mean by that is they correspond. And then we have a couple of other criteria. One, the corresponding angles are congruent. And two, the corresponding sides are in proportion. And so that's what we've been talking about. And proportion is you have two things that have the same ratio set equal to each other, that's a proportion. So another way of saying that too is that the lengths of these sides have equal ratios. Okay. So on the next screen I want to give you an example going through this. So we've got two polygons. We'll call this polygon PQRST. And I'm going to give you one piece of information, that the length of PQ is 20. And then we have another polygon. And we'll call this polygon VWXYZ. And one piece of information that will be given is that the length of VW is 32. Okay? And remember when we were dealing with congruence, the orientation of the vertices would be the same from the one triangle to what it was congruent to. So everything that corresponds, they're going to be in the same order. So if somebody tells you these two polygons are similar or congruent, that means corresponding vertices would line up. So we pay attention to how things are written. So let's go with that. Polygon, and by the way, five-sided figure, pentagon, PQRST is similar to polygon V, W, X, Y, Z. So this tells us a couple of things. First, I'm going to do a lot of different colors here. Let's do first. Our corresponding angles are going to be congruent. So angle P would be congruent to angle V. Also, angle Q corresponds to angle W, so angle Q would be congruent to angle W. Angle R corresponds to angle X, so angle R is congruent to angle X. S corresponds with Y, so angle S would be congruent to angle Y. And T corresponds with Z, so angle T would be congruent to angle Z. Second thing we know when we're told we have similar polygons is that their sides are going to be in proportion. So the length of PQ over the length of VW would be the same as the length of QR over the length of WX is the same as the length of RS is to XY is the same as ST to YZ, and TP is to ZB. Okay, so corresponding in order, all those ratios would be exactly the same. Now, one last thing to mention, this is not a card or anything, just to understand, is that we have all these properties that work with congruence. Well, several of them also work with similarity. So similarity is reflexive, symmetric, and transitive. Okay? All right. Now, related to this diagram is that we can actually gather some information from knowing that all the sides are in proportion and using those two red numbers that they presented in the diagrams that happen to correspond or relate back to the corresponding sides. So this deals with this notion of scale factor. So scale factor is the ratio of lengths of two corresponding sides in similar polygons. So if you remember above, we had talked about how segment PQ, or the length of PQ over the length of VW, is the same ratio as everything else. And then we know from the given information that the length of PQ is 20 and the length of VW is 32. And if I reduce that to lowest terms, and let's see, it looks like they have a 4 in common, I get the scale factor is 5 to 8. Now I'm going to give you an example in just a few minutes how we can use that scale factor to actually figure out missing lengths. So I do want to point out, let's go ahead, we'll get to that example and then show you something within that example. So what we have is two different quadrilaterals. We're going to answer several questions about them. So quadrilateral A, B, C, D is similar to quadrilateral A prime, B prime, C prime, and D prime. So this is another way of showing correspondence. Instead of having different sets of letters to use the vertices, we can correspond a vertex of one shape to the vertex of another using the same letter but adding a prime symbol, which is that little apostrophe. Let's see if I can draw a good picture of these. Probably not, but I will do my best. Yeah, they're not really very good, but anyway, we'll just use. So this is A, B, C, D, A prime, B prime, C prime, D prime. And again, we're given that they are similar polygons. So let's see what kind of information do I have. On the first polygon, we've got the length of AB is X, BC is 8, CD is 20, AD is 10. Let's see, over on the A prime to B prime is 21, B prime to C prime is Y, C prime to D prime is 30, and A prime to D prime is Z. In addition, angle A and angle A prime are congruent, angle B and angle B prime are congruent. So first thing we want to do is find the scale factor. So I'm going to do that over here. So what we're going to do is we're going to look in our diagrams and we're going to look for two corresponding sides where both the numbers are listed. So if you notice, AB and A prime B prime wouldn't work because AB is an X and A prime B prime is a 21. Same thing happens on the sides on the right, the BC and the B prime C prime. We have one variable, we have one number. But it's when we get to the CD and C prime D prime. Now, I'm going to keep things in the order that it was given to me. Actually, let me change this color. In the original information. So we're going to have CD is to C prime D prime as 20 is to 30, and then we simplify it and we get 2/3. So now that I know what the scale factor is, I can find the missing lengths. So for part 2, or part B I should say, we're going to find what X, Y, and Z equal. Okay? So what I'm going to use is that scale factor. Okay? And to do that, we're going to set up some relationships. So X goes with AB. So AB, and then its corresponding partner would be A prime, B prime. So X is to 21 as 2 is to 3. And then we do cross products, and we get 3x equals 42, divide by 3, and we get x equals 14. So there's x's value. And then let's look at for y, that involves the b prime c prime. So we're going to have bc is to b prime c prime. Okay, so we get 8 is to y as 2 is to 3. And again, we'll do cross products. We get 2y equals 24, divide by 2, we get y equals 12. And then we go to z, and z is that AD and A prime D prime. So AD is 10, A prime D prime is the z, and that's the same as the scale factor of 2/3. So we do cross products and we get 2z equals 30, divide by 2, and we get z equals 15. Okay, so that's using our scale factor. And then we're going to go ahead and ask you to find the perimeters of the shapes. So find perimeters of each quadrilateral. So we'll start with A, B, well, let's try this again. I'll do a color, how about that? We're going to find the perimeter of A, B, C, D. And to do that, we're going to take the lengths of all the sides. So X was 14, then we had an 8, then we had a 20, then we had a 10, for a total of 52. And then the other perimeter of the A prime, B prime, C prime, D prime. So we had 21, and we had Y, which was 12, and we had 30, and we had Z, which was 15. And we add them up, and we get 78. So the last question says, find the ratio of the perimeters and what we're going to do is put the ratio, or the perimeter of the A, B, C, D over the perimeter of A prime, B prime, C prime, D prime. And that's going to give us the 52 over the, let's see, 78. And these actually have two different, it's kind of hard to see what the common factor is. We can see that they're even. I'm just going to go to black at this point, and that's going to give us 26 over 39, and then they both have a 13 in common. And are you ready for this? Drum roll. We get 2 over 3. And in case that's not ringing any bells for you, remember what we got for the scale factor originally? 2 over 3? Is that coincidence? Something to think about. All right, good luck with your homework.